everyone. My name is Victoria Sandberg. I'm 15 years old and a sophomore at the American School of Milan. Every day when I wake up, I brush my teeth, I wash my face, and I keep myself clean, as I imagine you do too. I drink several cups of water per day, and it's safe to say that water is more than essential in my everyday life. But what if I were to tell you that according to the UN Water for Life, more than 748 million people still do not have access to an improved water source? And it's 2019. We were supposed to have flying cars by now. However, freshwater sources are not just essential to our hydration and hygiene. Other than that, universal access assures sanitation, which is fundamental to the increase available of benefits and prosperity. Furthermore, improved water quality helps protect our ecosystems, which are essential to sustain biodiversity. Over my time in education, I have seen my school put growing efforts into the sustainability of water. As a matter of fact, our campus does not sell plastic bottles anymore, but rather it allows students to have access to refillable water stations and filtered water fountains. Whether on the scale of a building or a nation, investing in freshwater management will decrease poverty and poor life conditions, while also working and sustaining economic growth associated to agriculture in less developed countries. The UN Sustainable Development Goal number 6 seeks to ensure sustainable withdrawals of water and increasing water use efficiency to allow more people to have access to clean and fresh water, where water is essential to maintain one's health and the production of goods and services like electricity and most manufactured products. It is safe to say that water affects us at 360 degrees, and being a limited resource, it is urgent that we look out for it. I also look forward to hearing more about this topic and the possible solutions. Thank you.
Hello everyone, my name is Gitanjali Rao, and I'm a promoter of science and an active inventor. In 2006, 540,000 people lost their lives due to lead exposure, and 13.9 years of healthy life was lost. These are just the statistics of Europe's water quality and the extent of contamination. How many of us are absolutely sure that the water we are drinking is safe and contaminant-free? How often do we test for lead contamination in our water? Why would we? It all started about 3 years ago when I heard about the water crisis in Flint, Michigan. Did you know that peak lead levels reached 127 parts per billion? That's 9 times as much as the EPA standards of 15 parts per billion of lead. I just couldn't accept the fact that there was a city in our country where children my age were exposed to a poison every day that caused lifelong damage to their mental capacity, vital organs, and even normal growth, just because they were using water in their daily lives. Surprisingly, this wasn't just happening in Flint. This is a worldwide problem, and we need to do something about it. I recently went to India, and lead in water is becoming a growing problem there due to an aging infrastructure, manufacturing processes, and chemicals in household products. About 33% of the top 26, about 33% of water samples from the top 26 cities in India tested positive for harmful content of lead. I've gotten requests from people in Brazil and UK about their water and what the health effects of lead are in water, because they've had family members who are diagnosed with chronic diseases because of lead in water. Health effects of lead in water can range anywhere from just headaches and nausea to possible seizures and even death. And it mostly happens, and it's mostly a problem because of the lingering effects it has on the human body. And the younger the child, the more impact. But how does lead get into water in the first place? Lead can get into the water through many different sources, such as old lead pipes, corrosion in old lead pipes, low-quality PVC pipes, solders in just the pipe joints, fixtures, and brass faucets. All of these are very common in many countries around the world. There are some current solutions today to detect lead in water, but they're either too cumbersome, expensive, or take too much time. They don't look at the detection, accuracy, and the contamination levels together. So I decided to create a device which looks at the detection of lead in water. Initially, I was looking at completely eliminating lead out of water. However, that was very complex, and it was like solving global warming with just one solution. So digging deeper, I found that the lack of knowledge of contamination and the extent of contamination was the bigger problem, as it kept people away from taking actions and finding alternatives sooner. So that's why detection became my primary focus. And I decided to create a device that solved the gaps in the current solutions today. Introducing Tethys, the quick and accurate tool to detect lead contamination in water. It's based on MIT's carbon nanotube sensor technology and provides instantaneous readouts on your mobile phone. Tethys consists of 3 parts: a core device housing a processor with a Bluetooth extension and power source, a disposable lead sensor cartridge, and a smartphone that connects over Bluetooth to display results. When I dip this cartridge into lead-contaminated water, the lead in the water binds with the chloride ions in the carbon nanotube, forming lead chloride molecules. This increases the amount of resistance to the flow of current and decreases the conductivity. The conductivity drop is correlated to the severity of the lead compounds in water. To make it easier for the user, I added an Adafruit processor to measure all resistance and current values, and it has inbuilt Bluetooth, so it can send the data to your mobile phone on an app that I created, which gives you values of either safe, slightly contaminated, or critical of lead status in your water. I performed all my tests at a Denver water quality lab. Tethys continues to evolve. Currently, I have made the device over 60% smaller and over 300% more power efficient than what it started out with. I'm using the latest controller and communication protocol, which significantly reduces its power needs. I have also worked on testing with other dopants, such as fluoride and iodide, to look at any false positives and confirm the accuracy of the device. I've updated the app to operate like an IoT sensor, so it's able to cloud source device data for analytics and civic planning as well, so that you can see a heat map on the app, which shows you places with more lead levels and less lead levels accordingly. I've also open sourced the sensor and analytics code for everyone to use. So, based on the evolution of my device, I'm continuing to still work on improving the device every day. But what I'm here to say is, while I'm here speaking about science, I believe awareness goes hand in hand. I'm actively testing water samples, writing articles, and speaking in forums like these to help spread awareness about the water quality issue. I've also partnered with the Children's Kindness Network, and I'm running kindness combined with science sessions for elementary schoolers, especially girls, since there needs to be more girls in science as well. I've partnered with Pace Analytics, and I'm creating reproducible prototypes of my device so that we are able to go to places like Flint and schools and do some real field testing to look at what actual results would be. I've been to Flint, and that's when I realized that I'd been taking my water for granted. It was just 2 days, and I had to live on bottled water, but it was so difficult. And that's when I realized that bottled water is not a long-term solution at all. I wouldn't be here today without the support of my mentors. Somebody believed in me and invested in my research. An incubator is guiding me with commercial feasibility on my device, and I've also had the most amazing problem-based learning provided to me at school. Innovation needs guides, it needs mentors, it needs companies and individuals that foster independent thinking, even if they are a little bit unconventional. So I believe that I would like to request one thing from each of you. It would be to seek a mentee and mentor them in the areas that they are passionate about, especially if it's relating to environmental changes. In addition, we can help by volunteering our time for the developments of science, by raising funds and promoting awareness, especially on water quality issues as well. So, I believe that I want to see a day where tethys is in each and every household. And testing for lead in water becomes a federal regulations in schools all around the world. I want to see a day where each and every one of us have the right to know what's in our water and have access to clean drinking water. Grazie.
In 2014, Flint switched their water source from Lake
I have a quick video as well, which I'd like to share with all of you.
Huron to the Flint River, and that caused lead contamination in drinking water. The part that hit me the most was that there are all these children who deserve clean water. I felt like I had to solve this. My name is Gitanjali Rao, and I created a lead and water detection tool with code. My device is named Tethys after the Greek goddess of fresh water. In order to test for lead in your water using Tethys, you attach a disposable lead sensor cartridge. If there is lead in the water, it causes resistance to the flow of current. The more resistance there is, the more lead there is. I taught myself how to code an app on Android App Maker, and I could see my results of safe, slightly contaminated, or critical. And I knew that if I could get this to work, I could help to never see another Flint water crisis again.
Thank you.
Good afternoon. What a hard job after these young scientists, Gitanjali. I mean, it's so difficult. I think I was calculating, I'm a 52-year-ago Denominator and young scientist maybe. In 1977, I would be here with 13 years old. We didn't have that plenary then, unfortunately. I was still raising my chicken on my German farm and looking on the farm of my parents and looking into that they have enough food and how could I sell these chicken once I get them as a little one out of the eggs, etc. You know, that was the time in the 70s when the Club of Rome was up and starting, when organic farming began in Switzerland as an idea to grow out of, to become even commercialized a bit as a standard as such. So, you know, being in an environment, and we had these questions to the innovators, and what was the environment? And recalling growing up on a farm, you know, who of you have ever heard from your parents, from grandparents, or from teachers, hey, come on, you're not going to make that. That idea is crazy. Don't even go that way, right? Discouraging things. To have this environment that actually stops you from doing and following your ideas. I must say, I've never had that, which is one of those advantages. And, you know, if you have kids or teachers, that is really the thing we can avoid, giving always the yes, you can type of approach. Now, years later in the 90s, when I left university, and I studied agriculture economics and food and supply chains, the BSE crisis, the mad cow disease, came along. And I always wanted to do some change in the food system. At that time, I was thinking, what should I do? Should I go to the government agencies, FAO or World Bank? I tested them both, but in the end, I actually chose a way to use the market power, the retail buying desks. At that time, concentration of the Walmarts of the world has actually begun. And so we had retailers starting, in the case of mad cow disease, for traceability of beef, made a change. So what I'm sharing with you today is not necessarily an innovation from this year, but it's something like 20 years ago when we thought, how can we do a system innovation, a food system change? Can we use the power of the buying to connect in the supply chain to instigate a change to farmers? Because in the end, every generation has the right to safe food. And you know, if we can and are able to encourage, to incentivize, to reward every farmer in the world to adopt safer and more sustainable production methods and then sell their product to consumers, that we have more food, that would be the ideal situation. Today we heard also that, yes, private network thinking of private markets is one way of doing so. We need also governments to change. But we have found that often government change is just too slow. So we thought, can we use buying desks to change this? We need to reconnect the farmer with the consumer. So we need to give them the feeling that when you go to your farm, and you are with the population now, more of half of the world population live in mega cities, you don't have that connection anymore. So how can we reconnect them, but still with the buying desk? And that's where the big retailers so far, I mean, online retail of food is still in its infancy. So the shopping and retail is still very much determining what type of food you can actually eat. So how can we connect that closeness in a partnership? And can we actually bring a vision? Can we help the consumer to see in that trusted environment, in that design? So basically with a virtual reality, walk through the farm and have that connectivity back. Well, it's a little bit of a future to mainstream this. I was always intrigued how we build a network, a global network, that we can harmonize in a partnership. SDG 17 would be basically my pick on the SDGs, in a partnership to drive change on farm level. So basically what we needed, and technologies are moving, and if you look around here, so many brilliant new technologies. We always struggle how we scale them up fast enough. When we see if we would always use what we have, we need the environment. In the end, I'm agreeing with a lot of also the IT companies, what's missing is really the governance. So we established in 2001, basically a roundtable that is worked on parity and consensus between the farmers on one side and their representation and the retail business. So if anyone goes too far or not far enough, they would walk away. So we created a consensus-based decision-making and basically developed something of good agricultural practice, a certificate that now reaches out to 200,000 farms in 130 countries worldwide. And I show you a picture of the retailers that buy into it, and they buy their fresh fruit and vegetable almost 100% based on a certificate of good agricultural practice, which is food safety and some environmental protection. Now comes the new issues, water. And the main innovation now we talk about, can we use these infrastructures of mainstream agriculture and also use for water? I brought this water bottle here as a symbol for water as used in agriculture. So we designed, and with some help of retailers, we developed a code of practice for preserving water, for calculating water, how much water is being used, encourage new technologies for drip irrigation instead of flood irrigation. I just made that symbol here. And we use this now, and the first major discount retailers, here in this case Aldi, for those that know the Aldi discount retailer, they have started now piloting this new technology. We did that with social add-on in injustice and child labor. We adopted this 5 years ago. We have now almost 100,000 farms of the 200,000 adopting a new social add-on. So this is now with water. And now creating this certificate network. The next big step is how can we even further scale up? For the last 20 years, we had basically a 10% growth, very, very steady of new farms going on board. Can we actually scale this up? Can we have even a disruptive technology that we now go exponentially? I want to double this year, next year triple, so we get in 2022 to 20 million farms. And the technologies I'm here seeing, I offer this framework to plug in, a framework that can connect with open API ecosystems of not just necessarily a platform economy, but also API ecosystems that machines talk to each other, and they can then plug into these growing number of farms. We recently, since we are in fresh fruit and vegetable, but we have livestock, we have aquaculture, we introduced a consumer label now. Now, doing that, coming from 20 years of business to business, now coming to the consumer edge, now we provide a farm portfolio, a farm portrait. Now we go back to that earlier picture. Now we have done the first sort of virtual reality farm, which you can use with your phone and a plastic or carton type of glasses, where you can see and stand on a farm. That's the experience we can bring for the city population. Next to, of course, urban farming, if you see those. So these are the groups of members we have been collecting in the last 20 years, and we've more and more signing up. A lot of them more than 10 years with us. You would see Asda, Walmart, Whole Foods, McDonald's. Recently, we signed up with someone like Tesco that would 100% their food safety requirements for all their purchases. They would let them certify and control with our global GAP assurance system. And with connecting now new data collection, connecting with businesses in AI, connecting with business IT and traceability solutions, I think we can digitize this, because the digitalization, the level of digital innovations in agriculture as a whole, in food, is still on the bottom of all the other industries. So I want to invite all of you and spread the word that there is a network. You can plug and play all the new technology, the innovations, and we can scale up together and make this a much faster trek to the better world. Thank you very much.
Hello, good evening, everybody. First of all, I wish to thank you for your presence here and welcome you here in Milan to this very important international summit. I have the honor to represent Prince Albert Foundation in Italy. I'm the chair of the Italian chapter. And as has been already introduced before by our prominent director, the activity of the foundation is to support any activity in favor of our planet. I think that the best solution, we have prepared a short film of a few minutes to introduce and to present you all the activity of the foundation. And then, of course, maybe the best solution could be that we are here at your disposal for any eventual information or for any help, maybe in the future, by getting and paying attention to the project that eventually you'll be submitted to the foundation itself. May I please to send the film, please?
Comment pourrions-nous laisser se dégrader encore cette planète qui est avant tout celle de nos enfants? Savoir et ne rien faire, c'est être au moins complice. C'est pourquoi il nous faut agir. C'est pourquoi j'ai créé il y a 12 ans ma fondation. Dédiée au climat, à la biodiversité et à l'eau, elle a déjà conduit ou soutenu plus de 400 projets à travers le monde. Certains sont très locaux, d'autres globaux. Certains sont conduits en partenariat avec des ONG de terrain, d'autres avec des laboratoires scientifiques.
La principauté de Monaco affirme plus que jamais son engagement dans la lutte contre le réchauffement climatique.
Avec des objectifs ambitieux supérieurs à ceux prévus par l'accord de Paris.
J'invite toutes les nations du monde, signataires de cet accord, à poursuivre et confirmer leurs engagements pour une cause qui concerne la préservation de notre Terre et de l'humanité.
La santé des océans souffre du changement climatique.
Le réchauffement des eaux met en danger les écosystèmes et nuit à leur biodiversité. L'acidification des océans affecte certaines espèces, telles que les coraux ou les coquillages. Pour préserver les mers, et en particulier les zones marines les plus sensibles, les aires marines protégées constituent aujourd'hui les outils pertinents.
Elles seules sont en effet capables d'offrir à des écosystèmes entiers les moyens de se régénérer, tout en favorisant le développement pour les usagers de ces mers d'une économie durable.
La Méditerranée, c'est près de 8% des espèces animales et 18% des espèces végétales, recensée sur la planète sur moins d'1% de sa surface.
La Méditerranée, c'est aussi, hélas, 60 000 tonnes de détergents, 100 tonnes de mercure et 12 000 tonnes de phénol déversées chaque année dans une mer semi-fermée, sans compter la moitié du trafic pétrolier mondial, les dégazages et les nombreuses pollutions qu'engendre un intense trafic maritime, sans oublier l'énorme problème des déchets plastiques. Le développement de l'homme entraîne dans une majorité de cas le déclin de la faune sauvage. La faune sauvage doit être l'objet de toute notre attention. Elle présente l'intérêt de révéler très concrètement les conflits ou les contradictions qui résultent de l'expansion permanente des activités humaines.
Tous ces enjeux exigent plus que jamais une attention particulière. Ils appellent une mobilisation globale. Ils réclament une action rapide et efficace. Les bonnes volontés sont de plus en plus nombreuses. Les moyens d'action paraissent encore souvent trop rares. Nous devons rester vigilants, déterminés et ambitieux.
Just one word before leaving you is that please remember that we have just one planet. There is no planet B, so we must act every day in this direction by taking into consideration all the deeds, everything we do every day. Thank you for your attention.
This is Hamad Beheshti from Boreal Light. Actually, the SDG says clean water and sanitation is the sixth SDG, but many of the others would not be available, or the poverty reduction would not be available without having access to affordable hygiene drinking water. So I'm talking about water and hygiene drinking water. We call it water kiosk. What we try to tackle is the issue of this green canister that you see there. These green canisters, they are called drinking water. By no means, by no definition, by no standard, they are drinking water. This is a water that most of the people in villages, even in cities, in urban communities, in East Africa, West Africa, they are drinking from. They are full of bacteria, viruses, many times fluoride, chloride, even salt. And you can see algae in those water without any, you do not need a microscope. You can see it by bare eyes. It's non-available every time. It's non-reliable and also unsafe. This is the cost of drinking bottle that I myself purchased during my living time in Nairobi, Mombasa, mainly two cities of Kenya. You see, the average cost of hygiene drinking water in this market is $4 for 20-liter hygiene drinking water. $4, 20-liter hygiene drinking water. That means, I'm talking about this kind of water. That means 1,000 liters of this kind of water costs $200. I'm talking about a market that with $70, $80, you can hire a person full-time, even on Saturdays, working for you from 8 to 7 in the evening. Not just drinking water is an issue. Remember, look at this picture. This one is a farm. Salt intrusion into the boreholes because of climate change is a very rampant issue now in the world, especially in East Africa, in West Africa, South Africa, even in South America. Look at that part. That part was irrigated by borehole water that was salt intrusion into it happened. And that part, no more farming is possible there. Just compare the part that is white, which is concentration of salt, to the part that was not irrigated. We are using a lot of farmlands in many parts of the world, especially in rural communities, because of salt intrusion into the boreholes. There should be a solution. This is what we try to do, and what we have done it. Affordable solar water desalination systems for off-grid communities. It has three main characteristics. It's running directly on solar, no need for battery, diesel, grid, nothing. Direct sun radiation and production of water. Simplicity. These solutions should be simple for those communities, and this too brings affordability to the off-grid communities. This is the way that most of our systems look like. If you come to my booth, A19, you can see one of our systems there. These two systems you see in these two photos are actually right now operational in Somalia. They are delivering water to thousands of people in Somalia. Then it's interesting. Producing 1,000 liters of water from direct ocean water to my system costs 50 cents per 1,000 liter. You remember the other numbers? Compare it to this one. This is a game changer for these communities. Then I said, why just selling my machine? I can sell affordable water to farmers, to villagers. This is the cost of water I'm selling. In villages, I'm selling 20-liter hygiene drinking water, the same quality of water that all of you are drinking, for 10 cents. Remember, $4. In urban area, in Nairobi, I'm selling it $1. Remember, $4. So this is a huge impact. And this one is just a drinking water. My work is not limited to drinking water. Remember simplicity. I told you about simplicity. 80% of the maintenance of this system can be done with one wrench, one screwdriver. You need nothing else. You can imagine easily how much of impact it brings to such remote areas, to such places that technical capacities are not available. My current focus, for 2 years, I've been focused in East Africa. Now I'm going to West Africa. In East Africa, I have projects from Yemen. At the middle of war, I installed system. Actually, 2 of my technicians right now, I send them from Germany to Yemen, and they are now doing installation in Yemen. Somalia, Kenya, Tanzania, all the safe places are the places that I'm working in. This is the way that my water kiosk look like. I have my machine at the back of the kiosk, and actually this is the standard model. Depending to the place we go, we change the architecture. And then we deliver water, those people who come to our system, we always have excess of electricity. So we give them free charging of their cell phones, whatever radio, whatever things they have. They freely charge it from our system. They receive the water. Even in some places, we have the Wi-Fi connection. Why? Because although the system is simple, but on its operation, we are doing a sophisticated remote monitoring. I'm sitting in my office in Berlin. I see my system in deep forests of Kenya, in deep deserts of Somalia. I see the quality of water I'm delivering to people. I see the pressure of the tubes. I see the volume of water I'm delivering. I see the solar panels, everything. I know any malfunction in my system earlier than the operators. This gives a huge capacity to me to take care of the machine, not just leaving it at the middle of the desert. I told you, my work is not limited to drinking water. I'm placing my machine at the middle of the village. From one side, I'm delivering drinking water quality. From the other side, I'm delivering irrigation water quality. These 2 different qualities, 2 different impact to the life of the people. And on the irrigation water supply, the whole machine is running automatically, delivering fertilizers needed for the farm and communicating with the sensors in the farm. These are some of the kiosks. You may have look at a different architecture based on different places. You see in this place on the right, top right, the ocean is just right at the back of the system. So it's telling you how much of salinity we can treat. These are some of our farms in East Africa, and simple, normal people in the village, freshly graduated from high school. Even some of them didn't finish high school. They are now operating the systems. They are capable, after 2 days of training, running the machine without having any problem. 2 examples for you. In this village, you see the borehole. Probably the lighter is not showing there. The brown one is the borehole. The blue dot is the location of the water kiosk that I'm delivering the water to people. Then I pump all the water all the way to the farm on the left. This is a farm that is receiving the water from the system, and it's a community farm. All the people, especially ladies in the village, they are growing their crops there, and then they share the revenue among the people there. And you know, every desalination system has also wastewater. We deliver drinking irrigation water, and the wastewater is a contaminated one. All the salt, chloride, fluoride is contaminated in the wastewater. What we do with it, look at that black dot at the top. We run it for the public hygiene toilets in a village. We run it for the flush tank of the toilet. It's saline. It kills the bacteria. It doesn't let the toilet to smell. And we also propose it for dishwashing applications because it's very clean. It's just salty. It's clean. You cannot differentiate between drinking water and wastewater. Both of them are crystal clean. One is just saline. The other one is drinkable. This is another project, it's in an island. We have again our machine. This big farm goes all the way down, and the girls, that one is a boarding school. The girls in the high school in that boarding school are the one who are growing their own food in this farm. We irrigate, we give them the fertilizer, organic fertilizers, and they are the one who are running to produce food for themselves. Until today, we are running 10 water kiosks in East Africa, and 40 orders we've already received, so it's a very active production time for us. And just in 2019, 20 more water kiosks are in a plant in Kenya. We've been chosen as the best European company in agriculture technology and food technology in 2017, and the national champion of Germany for innovation in agriculture. And you see the list of the activities and the potential clients and the current clients we have. And thank you.
Good afternoon. I'm Paolo Grisenti of Blue Tentacles, a startup focused on precision irrigation solution for industrial agriculture with main goal of water and energy savings. As well known, climate change is deeply reducing water availability worldwide, shifting in time and space rain patterns. Agriculture, main responsible of freshwater use globally, is affected a lot, and farmers have to face these events. But let's see some numbers. Food production needs to increase of 60% by 2050 and of 100% in many developing countries due to growing population and also to meet Goal 2 Target 2.3 that aims to double agricultural productivity. The problem is that in the meantime, we will have 20% less of arable lands, 25% of water deficit gap, with 4 billion people living under condition of important water stress. Worldwide, there are more than 300 million hectares of irrigated cropland, like 10 times Italian surface, and average annual water withdrawal is equal to 7,700 cubic meter per hectare. Irrigation is responsible for 70% of freshwater use globally, and 40% of current irrigation water use occurs at the expenses of minimum environmental flow requirements. That is, the daily river flow needed to maintain aquatic ecosystem services. This is in clear contrast with Target 6.4, sustainable withdrawals. As shown in a research published in 2017, if this volume were to be reallocated to the ecosystem in respect of environmental flow requirements, half of globally irrigated cropland would face production losses greater than 10%, with losses of 20 to 30% in Central and South Asia, but also in Italy and Greece, as shown in red in the lowest picture. At the same time, the research shows that implementation of irrigation practices can widely compensate for such losses on a sustainable basis. It is quite clear that the implementation of the ambitious and sometimes conflicting SDG agenda is a complex challenge for agriculture and irrigation market, but a lot has already been done. In fact, even if most of the irrigation systems are still surface irrigation type, water distribution efficiency has been increased moving to sprinkler irrigation and to drip irrigation system, the most efficient. Switching from surface irrigation to localized irrigation reduce water use by 30 to 60%. These efficient irrigation systems are usually automated, but irrigation management is usually only time scheduled. And irrigation works every day, also during rainy day or before and after enough rainfall, not considering weather, soil, and plant conditions. This is a huge waste of water, but we have technology to change and improve also irrigation system management. Our low-cost retrofit solution for precision irrigation is based on a field network of wireless nodes that turn on and off irrigation valves and continuously collect data from soil and environmental sensor. Data are collected through a low-energy LoRaWAN wireless network and combined with meteo data, satellite data, and weather forecast model. Data are elaborated and give a specific irrigation advice that is sent back to wireless node to automatically control irrigation system using water only when it is really necessary. To further increase the efficiency of the system, Blue Tentacle solution can be integrated with X-Farm agricultural management platform together with Hydroplan specific irrigation advice to manage all the activity of farms with a complete solution. With our smart irrigation solution, we are able to save up to 30% of water and 20% of energy. In a vineyard in Trentino, with average annual cost for irrigation of about 600 euros, it means reduction of about 170 euros per hectare per year. Data show that precision irrigation can have a strong impact on water use reduction, and only in the Italian market it is possible to save up to 3.3 cubic kilometers of water every year, like 2.5 times water annual consumption of New York City. Blue Tentacle solution addresses goal 6, increasing water use efficiency and reducing water scarcity, and goal 12, improving sustainable use and management of fresh water. Our solution also contributes to improve agricultural efficiency and production, as aligned with goal 2, and to reduce nutrient and fertilizer runoff by eliminating overwatering and overspray, as aligned with SDG 14. Thank you very much.
Good afternoon, everybody. I'm Andrea Caravelli, and I'm the CEO of Trillium. Trillium is a Swiss company. Something wrong? Okay. And we decided to open this presentation with this sentence because we believe that most of the things we are going to show you today in this presentation has to do with nature. We got inspired basically from what is already existing in the nature. So, but a little bit more into details who we are. We are a group of, I could say in a way, visionaries that have a lot of experience in commodities trading, that have decided in 2013 to base a company that works on innovation on different fields of business. Since last year, we decided to also open a branch in Italy. We started 2 people, and today we are over 60 in this time, all over Europe. But what is actually the vision of our companies? I think the most important part of the story is that it's to imagine, realize, and supply to people innovative and sustainable technology with the goal to improve the quality of their lives and to help them participating to regenerate the planet. It's quite an ambitious vision, but we started very carefully and we are going fast and faster. The technology we are engaged is concerning water, which is why we are here today talking about it, but also energy. We also produce special solar panels, able to do several things, hot water and electricity at the same time, but we are also involved in air treatment, air cleaning. More specifically today, I want to talk to you about the water technology, and the subject of this technology is ultrasonic and hydrodynamic activation of water with micro and nanobubble generation. I will now show you a short video to just understand what it's all about.
The T-Sonic line is made up of a series of devices that work according to the principle of hydrodynamic activation, a physical phenomenon generated by mechanical oscillations which, thanks to the geometry of the device and the discharge pressure, produce ultrasounds. The particular generated frequency has a direct effect on water and, without the use of any chemical agent, it guarantees the elimination of limescale deposits, the inhibition of bacteria, and the reduction of viscosity. More specifically, T-Sonic OM is an activator for civil and industrial use that is particularly indicated to eliminate limescale deposits while contemporaneously preserving the chemical qualities of water. T-Sonic PW is an activator for swimming pools and spas that can eliminate the bacteria, reducing or even eliminating the use of chemicals for water disinfection. T-Sonic GH is an activator for agriculture, capable of increasing the oxygenation of water, decreasing its viscosity, and improving its ability to solubilize nutrients. T-Sonic OM, T-Sonic PW, T-Sonic GH, technological innovation for a better quality of life.
So you have heard speaking about water activation. So what actually means water activation for us is that if we know how a water molecule is made in nature, we also know that this molecule get together, binded by hydrogen bonds, and create a complex cluster of water molecule. So for us, activating the water is meaning generating a form of energy that in our case is hydrodynamic and ultrasonic, okay, able to do this, to break the molecules into a smaller group of molecules. Why is it interesting to do that? Because we have effects on the lime scale, we have effects on the bacteria, as you've seen in the video, and also in viscosity and water surface tension. The products that we have concepted according to this aim is T-Sonic OM, T-Sonic PV, and T-Sonic GH. Those three devices are used in many applications. Lime scale, it's a big issue in Europe. We know also in the irrigation system. PV, it's a device that is allowing to have swimming pool without chlorine and anti-alg as a chemical product, and GH is device made in farms and agriculture. Micro nanobubbles, in this case, are bubbles who are smaller than 50 micron, and they have a negative charge on their surface. This is interesting because it's guaranteeing us oxygenation effects, cleansing effect, and flotation effect, is in domestic application as for the industrial. The products into the microbubble field is T-Wiro, that is normally installed on the pipeline in order to oxygenate the fluids, not only water, as you will see very shortly, and T-Wearable, which is a device normally used to oxygenate and put it immersion in fluids. But the combination of those two technology, activation and microbubble, have led us to this T-Sonic GH, which actually is a cylinder from stainless steel with a specific geometry inside, able to generate ultrasound only to the flow pressure of the water going inside. So the ultrasound are generated naturally from the water flow on the existing pipeline. This device is able to increase the oxygenation, doing higher speed of solubilization, either fertilizer or the minerals who are already existing in the soil. And also with viscosity reduction, it means that the water drains faster to the roots. Here is one example on parallel to see what does it mean to irrigate with activated water and with normal water. Okay, this is a strawberry test made on an open field. This is a tomato, cherry tomato greenhouse we have made in Sicily. Very successful, and this study was made with Agricultural University of Turin, where you could see the rucola with and without activation. But at the same time, as we said before, for swimming pool, not less here in GH, we can also avoid the algae formation. Okay? All those products are certified and patented. We started in Switzerland, and we are proudly saying that we produce all our technology in Italy, near Milan. On the R&D side, we do several more applications in the mechanical industry, food process, fish farms, and wastewater. Our new project, it's our own farm, which we have started near Malpensa Airport in a village, where we are trying to do a demo where we combine all our technology we have developed until now in these years. So it's water treatment, production of electricity with our own solar panel that heat and cool the greenhouses, heating system, as I was saying, in the wintertime, but also air treatment with our air filtration system inside the greenhouses. This is the method of hydroponic we are doing at the moment. As you can see, there are a combination of all the technologies installed. But at the same time, because we all know that digital is a very important part of our future, we have combined the hardware of T-Sonic GH with the software of a system able to communicate how much fertilizer I need to put in my hydroponic system, and then to blend it even better thanks to the mixing quality that this device has. The last one we made, it's T-Cunic, because we have seen that we can treat not only water, also other kind of fluids. So in the food industry, we could make several tests to see that when you have to keep an emulsion stable without using chemical products, we are able to do it only with the same principle of hydrodynamic activation. So we made a device able to keep the emulsion stable for days and days. Okay? In the ice cream was even the more shocking test we made. We could see higher emulsion stability, viscosity reduction, higher density, higher shelf life, and less flavor needed, thanks to this activation phenomenon. Okay? If you would have any deeper information, we are at the stand A16. Thank you very much for your attention.
Good afternoon, good evening, and thanks to be here today, and thanks to organizer to all of my presentation here. And after hearing a lot of solution, maybe it's time to listen to the big picture and to the problem that we know. I mean, all the solution were starting from the problem. But so I will try to give an overview of this issue of water for agriculture and food production in general. The Earth forms space. The Earth is a blue planet. Blue planet means a lot of water. But most of that water is not available for us, I mean, for our use. Actually, in these nice bottles that we get here to avoid pollution, these are recyclable. These are done by Seeds&Chips, and it's written here. Less than 1% of Earth water is available for human needs. So mostly it's salty water, and actually we have listened also to desalination problem. Some numbers. Annual precipitation over the land is more than 100,000 cubic kilometers of water, and about 30% of that is due to terrestrial plants. So terrestrial plants, forests mostly, but also agriculture, grassland, are 32,000 cubic kilometers of water to the atmosphere. This means 2 times the water content of the atmosphere every year. And you see here the different amount of precipitation in the different area of the world. But we have a lot of water, but also some debits. And the debits are much higher at lower latitudes and dry tropics. And while at the humid tropics and high latitudes, there are almost no debits. Everything that is from white to red, it means a water debit compared to what is needed for agricultural production. And actually, the natural productivity of land depends largely on water. Here is a map coming from satellite models and data, meteorological data and flux towers. And everything that is red and red means the correlation with the productivity of that part of land with the available water. It's more direct. So basically, water control productivity. But climate is changing. We have listened several times to this also during the previous presentation. You have not to read that. I will read for you. That basically, we have seen already warming, and it's very likely that we have seen that. We have seen drought. It's likely, but in some areas, particularly Mediterranean. The future, we will have likely warming in the early 21st century, so now, and virtually certain warming in the late 21st century. We have low confidence to have more drought now, but it's very likely that we will have more drought in the future. And actually, we are seeing a decrease in precipitation somehow. This is actually now, you see on the left is 1901 to 2010 compared to 1951 to 2010, and the brownish area are increased. This means less precipitation per decade. Drought is already now is the largest cause of damage to agriculture. You see here, this is data from FAO. 83% of the damage to agriculture comes from drought, much more from the very, let's say, more terrific volcanic eruptions, storm, floods, tsunami, or earthquakes. So drought is an issue. And in the future, the irrigation needs will be larger. So we will need much smarter irrigation solution. And you see above it's less problematic because the model there have considered a CO2 effect, because CO2 can increase the water efficiency of vegetation. But if you look at the behind the world map, everything that is from gray to brown means an increase, percentage increase in irrigation need to match the current productivity. So we need more and more water. And which will be the impact on crop production. And you see here from, let's say, now, basically, to the end of the century, and even further, that basically the crops that will have a positive impact of climate change because of increasing temperature in the temperature-limited regions. You can have an increase in production, but not in the temperature unlimited region. And you see that the orange, brown, and red are increasing and increasing as we move forward to the future scenario. So we need adaptation. We need adaptation and we need technologies. This is an example from Italy. These are the irrigation district in Italy, and basically to show that there is space for irrigation improvement. And basically all the red, it's, let's say, less efficient irrigation techniques, and on green are more efficient. So basically 80% it's higher dispersion, while 20% is more efficient. So there is space for improvement. But still, the agriculture, it's one of the more use-efficient sector for water. So the water that is coming in, it's used very efficiently in terms, there is no waste, compared, for example, to civil use. And something that we have seen some solution during the talks that were before me, but this is also an idea to have precision irrigation using precision agricultural techniques like coupling, proximal sensing, sensors, and irrigation gauge. This is a project together with my institute and Israel on this issue. And actually, adaptation is the real key to the future. This is if you see the white rectangle there, it's without adaptation. So we will have degradation, loss of ecosystem services, loss of human well-being, increase in pressure, and this will be a negative feedback loop. While with ecosystem-based adaptation, we may protect and restore ecosystem, improve biodiversity, reduce vulnerability, and so on. So what we really need is adaptation, and we have the technology, and we have to move to that. Thanks.